Hey guys, how's it going? Welcome back. So today we're going to talk to you about voltage, resistors, and LED bulbs. Now, I've been in electronics for a really long time, many years. About 32 if you want to get technical, going on 33. I never really got to play with LED bulbs a lot, and so I've been learning a lot in the last 48 hours about LEDs. I run LED lights in RC helicopters. A lot of my RC toys use them. But what I want to do is put a really good powerful headlight into an RC helicopter. So, you know, I thought, I got these ultra brights and I want to use them, but I'm running an 8.5 volt system. I know that these are 3.7 volt because that's what the guy I got them off of told me. So I figured, how do I get this down? Need a resistor, obviously. I already knew that. I got to reduce the amount of current going to it, but by how much? Enough to get down to 3.7 volts or slightly below. So what happened originally with this was I did some research, of course, because I'm new to LEDs and so I didn't know exactly what size of resistor, because you can't just slap any resistor on that you want. That's the thing. So I checked on the internet and I found one place where it said, 160 ohm resistor. So off I go to Radio Shack, aka the source, and I picked up a pack of 100 resistors, but a 160 wasn't in there, but a 180 was. And I thought, hey, good, I'll reduce it even further. That works. So I hooked her all up, plugged her in, 30 seconds later, pop! I blew a bulb. Tried that again, thinking maybe I accidentally shorted something. Nope, sure enough I didn't. Popped it again. Okay, this is ticking me off, and I did find an online source where I can get these bulbs in bulk, so I'm going to be ordering in a bunch of them because I want different colors. I want, but I also want the ultra brights, and these are going to come with resistors already designed for 12 volt applications, which should work out to be a great benefit when I'm running 8.5 volts. I should be able to use the same resistor, have no hassle, because 12 volts is higher. Okay, so, and I'm getting the 3.7 volt version of these, so at least I'm sticking with something that I already know about. Because when you buy a pack of these things brand new, generally like in your local Radio Shack, it'll tell you like a little bit, it'll tell you the voltage, right? But it's not going to tell you what resistor to use with it, because they have no idea what kind of voltage you're trying to jam into this sucker. So you need to figure out, okay, how much voltage am I putting in? How much do I got to resist it by? I need a box of these. So, you're going to go through them. The higher the value of the resistor, the more it's going to resist electricity. So, I got all the thing figured out, and I'm at 1.5 kilo ohms is what I need to drop the voltage just below 3.7. And this will allow the bulb to run like forever, because I'm not maxing the bulb, I'm actually going slightly under, right? And being an ultra bright, it's still going to be bright enough even at, 0.3 of a volt difference, which is like squat. So, instead of playing around with these, I still hadn't known right away that I needed, the 1.5 kilo ohm. So I built a 1.5 kilo ohm out of 8 resistors. Now, these aren't all 8 the same. There's 4 that are the same of one size, 4 the same of the other. Do the math with the number, add it up. It comes out to 1.5 kilo ohms. So, my end result ends up like this. We take the negative, put it to negative, positive to positive. Our battery's pushing about 8.26 volts right now. It's actually pushing about 8.5, but I've been using this to guinea pigs, so giving you a rough idea. Now, it doesn't matter which direction your resistor is, because the electricity flows both ways. Okay, so it doesn't matter which direction the resistor's on. You can put the resistor on the positive side or the negative side. Just make sure that your longer lead, which is on your LED, your longer lead is always your positive. So if you're going to put the positive raw, hook your resistor to the negative, or hook your resistor to the positive. It doesn't matter. But whatever side the resistor is on, that's the side that's got to go in on here. So if your resistor is on the positive leg, then you got to plug your resistor into the positive side of your power, like so. Now, we're going to go negative here, and we're going to show you off the first resistor, we've dropped it down to 6.65 volts. Let's go to the fourth resistor, 4.8. Let's go to the seventh, 3.59. I can run this with 7 resistors, which is 3.59 volts. Now, do the math, you got to figure out what's the kilo ohm rating now for 7 resistors. Well, I know for a fact for 8 of them, and the combination I used, I'm at 1.5 kilo ohms. So, and I'm at 3.4 volts, which is fine. So when I go and I hook this up, without shorting stuff out, because that would really suck. I've got power. Whoops, fell out. So I've got power. My bulb's running pretty good. It's nice and bright. You know, no problems there. Nice and bright. Whew. That's going to look nice in the helicopter. It's going to even look nicer with the chrome casings I'm buying for them. So, when I get these things in, I'm probably going to have no problem just using the resistor that they package with it, because it's for a 12 volt application. So 12 volts and under, I should theoretically be fine. We're going to find that out for sure once I get them. So I'm going to have to order those in, and they'll come with resistors for the LEDs for the 12 volt app. And then of course I'm ordering these really cool stainless steel looking cases that each light goes into and it mounts in. You know, it's going to look really, really super sweet. And I'm going to go with the 10mm for the headlight because I want a nice bright, and I want it nice and wide patterned out. So that's what I'm going to go with. And the brighter the better, right? And then where I hook this into the helicopter, that's a whole other story, but at least now I know that all this adds up to 1.5 kilo ohm. I do have a 1.5 kilo ohm resistor. So now my next step is to get this thing out of the way, snip off my lead nice and short, hook this one in to here, put some shrink tubing on it, leave the other end with just enough sticking out to hook the wire into, so I can heat shrink that area with heat shrink tubing, hook my main wire onto here, which means I got to cut this back to a specific length, and go from there, and then I can install it and wire it into the helicopter. And it's going to be pro, right? Because this is definitely not pro, but this is how I found out by doing this to get the number here, which voltage one at a time until I was happy with what I wanted, and then I got my final number. My color code I found out was brown, green, red for 1.5 kilo ohm. Went into my case, got the 1.5 kilo ohm. Boom, I'm all set to rock and roll. Now, you want to switch your power source? Start out with 12 volts. This is something you'll find is a little bit of a change. Okay, this is my positive, and this is my negative. Now, I'm at 12.47 volts off this charger pack that I just hooked on. This is plugged into a power cord. Don't want to short those out. Now, doesn't matter which resistor I put where. So, now, we're going to hook this up again. Now, of course, this is polarized, so we got the negative on the wrong, positive on the wrong side. So I'm at 4.7 volts even. Now, that's 1 volt too much for that bulb. So 1.5 kilo ohm is actually too small to bring that down to 3.7 or 3.4 volts for 3.7 volt LED. So when you're working with a 1.5 volt LED or different and so on, and it depends on how much voltage you're driving. If you're driving in 100 volts in your system and you want to put one of these LEDs in, you need to use the appropriate resistor or combination of resistors, because you may have to build a resistor pack in order to get that voltage to drop low enough that you can hook that LED in without any problem. Okay, and that's exactly how things work and how you step-by-step guinea pig this stuff. So when you're looking on the internet and all you know is your voltage of your bulb, You know, you have to say, okay, what's the voltage of my bulb? My bulb is 3.7 volt. Okay, or my bulb is 3 volt. Well, I got a 60 volt power supply. There's calculations, there's programs that you can calculate to find out exactly what resistor you're going to need, so you can just go out and buy just that one resistor if you want. I like to buy them in the boxes of 100 like this because it gives you a lot, and you usually get like at least 2 of each size, which is nice. So basically you've got about 50 different resistors out of the 100. And that's not all the resistor sizes out there. There's tons. So, you know, when it comes into wattages of resistors, that's a whole other ballpark altogether. But for doing this sort of thing with just, you know, batteries, this works quite adequate. This works quite adequate. These big resistors are useless. I tried these, but I mean, this color code setup for this resistor doesn't exist on my program, and I didn't feel like looking it up, so I just guinea pigged it and tested the voltage, and it didn't even hardly drop. You know, I would have needed a couple dozen of these just to get it down to that voltage, so that was a waste of time and energy, and I didn't have a couple of dozen. So I thought I'd go to the next size down, and I stripped them out of these charger boards. So they worked rather well. So that's how you figure out what resistor load you need to the LED that you're using for its voltage versus the voltage you're sticking into it, and you'll figure it out, and then voila. Now, if you don't want to build a resistor pack like I did, you can just go through all 100 of these suckers, dump them out, and do one at a time and check the voltage until it drops to where you need it. That's another way to do it. Okay? I didn't want to do that with 100 of them, so I kind of shortcutted things a little bit. Because I already know the numbers and how I can add them up. Just based off the first one, I knew, okay, I'm going to need a couple of them, so I got 4 the same of one size, 4 the same of the other. And I just kept going along the line until the voltage dropped where I needed it. And turned out, you know, all 8 of these, 4 of each size, worked great. So then I found out the number, added it all up, and pulled out this 1.5 kilo ohm. That's all I need. Boom. Done. Okay? Works great. So anyway, hope you enjoyed the video. If you have any questions, feel free to ask. I'm going to do other videos where we're going to talk about, you know, like diodes and transistors and all that sort of thing. Eventually I'm going to get to those videos as well and explain how those different circuits work, and, you know, what you can, some of the things you can do with them anyway. And we'll just continue on. So thanks for watching. We'll see you on the next one.